Okay, so we have made it to layer 3, the transport layer. In this case, the transport layer that I'm talking about is TCP. This is not the only transport layer that IP can handle, but it is the one that is used in this connection type. So HTTPS, we're looking at TCP. I've opened here the Wikipedia page for TCP, and you can see TCP is one of the main protocols of the IP suite. The other really common one you'll see is UDP, and then there's a bunch of others which are sort of dependent on special cases. So, we can see in the TCP packet some information, and what I'm going to do is I'm going to regenerate a new TCP dump for us. So let me restart our capture here, and what I'm going to do here is I'm going to connect again to the server on port 443, and I'm just going to send the text hello to the server. Now, this is not a valid connection, so what we're actually going to end up with here is we are going to just get disconnected with a like, oh, you're not sending me the right data. But it still will demonstrate the TCP connection for us. So I'll just restart that again and hit go. Cool. So we have now a packet capture, and I'm going to stop this connection, stop this capture. So we have a bunch of packets here. So with our TCP packets, we have them all encapsulated in Internet Protocol version 4. And so if we work our way through, we'll see they're all encapsulated in IPv4. We've already talked about that, so let's have a look instead in this TCP section. Now, just jumping quickly back to the Wikipedia page, we can see that the TCP segment structure, so this is the layout of the packet. It contains a whole bunch of information. I'm just going to zoom out a little so we can see it properly. Yeah, there we go. So it contains a whole bunch of information: the source port, the destination port, the sequence number and acknowledgement number. Then there's a bunch of flags and information, window size, checksum, urgent pointer, and then a data block. Okay, so TCP is what's called a reliable transmission protocol. So it includes some extra information to try and guarantee that the data that's sent was actually received. So it contains a checksum to validate the data packet, but it also contains these sequence number and acknowledgement number. So you send a connection and then you get an acknowledgement and then you acknowledge the acknowledgement. That's what those are. Now, let's have a look at the actual TCP connection because we will see this in action. So to start the TCP connection, we first send a TCP packet that contains this flag SYN. So this is like SYN as in sync, connect to the server. And there's a diagram here on the Wikipedia page that shows the flow of the packet connection. So you make a connection and you send a SYN connection, and the server will send you back a SYN acknowledge, and then you acknowledge that. At that point, you have an established connection, and you send a bunch of data back and forth over this established connection. Once you're done, you can send a FIN, as in a final packet, and then the other server, the other host, can acknowledge that, and then the connection will be closed. So we send from us to the server, we send a SYN packet. We say, we want to connect to you. We can see here the source port. And so the source port, that is the port on my computer that we are connecting from. And that's a randomly chosen high numbered port. We can see the destination port. And this is the 443 that we selected up here. HTTPS specifically is going to listen on port 443. So we need to send that as the destination port. But we can choose any source port, and when the server receives this packet, because it contains this source port, it knows where to send the data back to. It also contains a sequence number. Now you can see that Wireshark has provided here the sequence number in the raw format. It's an enormous number. And this sequence number is just selected by the computer to separate out TCP connections and the sequence. But Wireshark is going to actually give us this relative sequence number. So it's going to remember the sequence numbers and increment them from 0 for us, makes it much clearer to follow. So I'm only going to talk about these relative sequence numbers, and you see the same thing with the acknowledgement number. There's an acknowledgement number and a raw one as well. I'm only going to talk about the relative ones. On the packet, they're actually going to be different numbers, but the decoded one is much easier to follow. We then also have the header length, it says how large this packet is, and then the flags. And these are the flags that we were talking about. So we started off by sending a SYN packet. We want to sync with the server. Okay, so the server sends back to us a SYN acknowledge, and you can see that the source is the server, the destination is us. So it's sent back to us from the source port 443. So it's coming from that server's port back to our destination port. It has set the sequence number and also the acknowledgement number. And it has said, okay, I see your SYN packet and I will acknowledge that SYN packet. That's all it's saying. It's basically saying, yes, okay, we're good to connect. And at this point, we then send back another packet. And we send it from our source port to the destination port, and we say, okay, yep, we're on the next sequence number, and we acknowledge your acknowledgement, so an ACK packet. Okay, the connection is now initialized. At this point, we actually want to send some data to the server. So these first 3 packets are all about sending, just making the connection, establishing the connection. So, but now we have the next packet, which is an acknowledgement. We say what we're acknowledging, the last packet that we've seen that we're acknowledging, and we also say push, as in we are sending you some data. There is data in this packet. And you can see that there's this block at the end which contains the actual data. And this is the hello. We said echo hello to Netcat. So we sent to the server the word hello. So we said hello, and the server sends us back an acknowledgement of the packet we sent. Now the server also sends us back some data. What the server sends us back is a TLS connection error, effectively. It's basically saying you've connected to a TLS connection and you're not negotiating TLS with me. You're supposed to negotiate TLS. So this is a bad connection. And you can see that the server has also set the push, as in I am sending you a little piece of data at the end of this. And that data packet is this TLS connection. We send back an acknowledgement that we received that packet, and you can see Wireshark is highlighting when we get this acknowledgement what packet that is being acknowledged by this ACK packet. Now the server sends us back some more, so it doesn't stop, it actually sends us back another packet. And what this contains is another block of data. And what this block of data is, if I expand it a little, is this HTML head, blah, 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 blah. That's actually what we're seeing here in the terminal. So basically, the server has sent us back a block of valid HTML. Now this is for browsers that incorrectly try and do a HTTP request over the HTTPS port. And so it sent back some HTML that the browser would render, which would tell the user of that browser, hey, you're trying to send me unsecure data over a secure port. You should negotiate TLS over this port. Now, looking back to our packet capture, we see we acknowledge that request. And now we receive from the server this. So it's another TCP packet. No data this time, but it contains the flag set fin. And what this fin is the final. It basically is saying, I am closing the connection with you. So the server has said to us, okay, you have connected to me over, and you've sent me garbage data on my HTTPS port. I sent you back a block of text saying, hey, you've done something silly. And now the connection, the server is actively saying, and I am closing your connection. It doesn't want a connection open with us if we're sending it garbage data. And we send back a fin acknowledge. We say, okay, yes, we see the connection is being closed. And we get a final acknowledgement back from the server saying, okay, I'm acknowledging it. We're all closed. This is the end of our TCP connection. We started the connection, we sent hello, some data to the server. The server sent back, hey, you've sent me garbage data. I'm closing the connection, and we acknowledge that. Both sides have now closed the connection. Okay, jumping back to our diagram here. We can see that now we've demonstrated this layer 3, the transport layer with TCP. We actually even saw a little bit of layer 4. We sent some data across the TCP connection. We got some data back across the TCP connection. This has been a good demonstration of this connection. Of course, in this case, we sent rubbish data. We got back not a rubbish response, but a response saying, hey, don't try this. But we've demonstrated level 3 pretty effectively. Basically, TCP provides us with a connection protocol and a way to send data back and forth. Next, we're going to have a look into that layer 4, the application layer.